started introducing our speaker. First of all, let's talk about what we're going to learn today. So this 9:30 to 10 a.m. session is called Digital Infrastructure for the Next Generation. The abstract is nearly 40% of our roadways in the US need to be repaired or replaced immediately. Emerging smart cities and smart mobility technologies are demanding access to the right-of-way, which is forcing public agencies to think differently about how future roadways are designed, built, and utilized. Integrated Roadways Sustainable Digital Infrastructure Platform Smart Pavement is a prefabricated pavement system with embedded sensors and networking elements designed to survive the harshest environmental and traffic conditions. Smart pavement will be discussed in this session, which I know we talked about a little bit in the keynote. And joining us today is Miguel Yaramillo. Did I get that even close? I am so sorry. He has more than 20 years of executive management experience in the public and private sector, having worked with companies and public agencies focused on education, healthcare, civic leadership, and transportation initiatives. At Integrated Roadways, Miguel's office is responsible for building large-scale, long-term P3 opportunities in the top 150 markets and leading DOTs across the country. His vision to transform the nation's transportation infrastructure system and meet emerging safety, mobility, and sustainability challenges is built upon leadership, innovation, and collaboration. Integrated Roadways has been featured in numerous national publications and other media, including CNN, The Wall Street Journal, Forbes magazine, and was recently listed among Business Insider's top startups shaping the future of wireless EV charging. So Miguel, I'm going to turn it over to you. I see that you are on the screen. Please, all of you, if you have questions, put it in the chat. Miguel, take it away.
Yes, thank you, Lisa. Can everyone hear me okay?
Yes.
Great, perfect. And I'm assuming everybody can see my opening slide screen as well. Great. Well, thank you, Lisa. And good morning, everyone. It's a pleasure to be here, an honor to be here. Actually, I've got to thank some of our friends in the engineering community for reaching out to us a few weeks ago and suggesting that we submit an abstract for the Transportation Innovation Summit. So it's a pleasure to be here. I think it's actually very fitting that we're also following Secretary Lorenz. There's a lot of words that I was jotting down as she was kicking things off with us this morning around partnership, innovation. She was really talking about scale when she is really addressing getting some innovation pilot projects off the ground and then building to scale. And then also just how we are going to really address some of the immediate infrastructure needs that we have today while also planning for the future. So I appreciate the introduction. As the Director of Business Development at Integrated Roadways, my office's primary responsibility is to engage the public sector. So we do a lot of work with municipalities across the country and are beginning to have more conversations with departments of transportation that are focused on improving the safety, smart mobility, and resiliency challenges that are faced with our nation's infrastructure system. We are headquartered here in Kansas City, as Lisa mentioned. Majority of us that manage the company are from Kansas. So we bypassed the opportunity to go to the West Coast or East Coast to launch our smart infrastructure technology firm. And we've got a really great Kansas story to share. So with that, how Integrated Roadways came about was through our founder and chief technology officer, Tim Sylvester. Some of you on this call and at the summit this morning may know Tim Sylvester by name and by work relationship. And what he has done is pulled together a team of misfits of entrepreneurs and engineers, both on the computer science, electrical, and construction engineering side, as well as folks that have a network operating background. And what collectively we do at Integrated Roadways is started with the initial premise of how do we build roads that last longer, construct faster, are cheaper to deploy, but also are extensible. And so we started with that premise around creating one of our core products known as Smart Pavement, which I'll get to here later on in our presentation. But we really began to address a much larger question, which is, what if our nation's aging, crumbling roadway liabilities could be transformed into a smart, self-sustaining networking platform, also while providing valuable digital services for connected electric and autonomous vehicles. So we've already kind of explained a little bit about, where we want to go with the next 10 to 15, 20, 25 years. We've also highlighted just the current challenges that we're facing. So I want to add and expand a little bit about the introduction that Lisa gave. So we know that nearly half of our roadways in the US need to be repaired or replaced immediately. Not only that, cities and states continue to experience growing budget constraints and are still managing the impacts of the pandemic. This has also helped create a national backlog of $8 trillion in unfunded roadway improvement liabilities. Now, this national backlog is also due to historical rigid set of funding mechanisms that impact the overall procurement process. Emerging technologies that support smart cities, smart mobility, and plans for connected electric and autonomous vehicles are also demanding access to the public right-of-way, which is forcing cities, public agencies to rethink how roads are designed, built, utilized, and maintained. In talking to several DOT leaders across the country, they put it a little more bluntly. They were not prepared for all of these emerging technologies that are needing access to the right of way, and they likened it to either being dumped over the head with a cold bucket of ice water or being slapped in the face. And so while we appreciate their honesty and transparency, what we're working on right now is to help them meet their immediate needs, again, while also addressing the future. So just a little bit more about integrated roadways. We are a leader in an emerging smart infrastructure industry. What we are doing right now is unlocking that untapped $8 trillion market by partnering with municipalities, financiers, and contractors and supply chain partners to transform traditional roads into smart, self-sustaining, revenue-generating managed services platforms. So we are focused on repairing and upgrading roadways in the top 150 municipalities in the US. And we're actually getting started with an innovative leader known as the City of Lenexa, Kansas, that Secretary Lorenz actually referenced earlier, as part of their 2040 objective, which is to build an integrated transportation and infrastructure system. So we'll talk a little bit more about what we're doing with the City of Lenexa and how the Kansas Department of Transportation and Mike Floberg's Innovative Technology Program is supporting that project. Smart infrastructure to us is the integration of data, communications, power, and networking systems into core infrastructure like roads, highways, and bridges. The company's main product is Smart Pavement, and you can see that up there on your screen there. It's a prefabricated, modular, precast paving system with embedded sensors and networking assets. Smart Pavement's innovative design allows for rapid installation, allows for removal and replacement for temporary utility access, allows for, obviously, for you to get in there and upgrade, provide subgrade improvements and roadway upgrades. Precast, as some of you all may know, is a proven and reliable method to build transportation infrastructure for these very reasons. It actually is proven a reliable method to build transportation infrastructure that constructs faster, lasts longer, and requires less maintenance. And it has a lower total cost of ownership over your traditional construction methods of asphalt and cast in place methods. So by design, our sustainable digital infrastructure platform is upgradable. So there are expansion ports, as you can see there on your screen, that allow us to accommodate both construction or post-construction installation, upgrade, or removal of sensors and communication antennas without harming the pavement or delaying traffic access. What you need to understand about Smart Pavement is that it's always going to be manufactured to specifications. So whatever the state DOT or if the local municipality has specifications for pavement, it's always going to be manufactured to spec. right? So each smart pavement slab delivers a wide spectrum of operational and capability improvements to traditional roadways. So it's digitally enabled driving surface, provides our traffic data as a service. So one of the core benefits that we're delivering to public agencies right now is what we refer to as TDAS, or our traffic data as a service. So through the sensors in our road and through our networking elements, what we're able to do and provide to public agencies are ESAL counts, vehicle counts. We're actually able to provide vehicle speed at the 85th percentile metric, weigh in motion, pavement condition indexing, and believe it or not, we're actually able to provide the exact vehicle make, model, and production year range of every vehicle that drives over the road, as well as socioeconomic and demographic profiles. All of this is fully anonymous, right? So all of this is through the sensors that we have and the networking elements that support our smart pavement system. Furthermore, some of the benefits that we're able to pull through our smart pavement system is the networking elements and the edge. So some of the cities that we're talking to have done some type of study that is identifying a gap analysis when it comes to Wi-Fi connectivity or 5G small cell antenna deployments. As you know, telecom is working their way through the public permitting process, procurement process to build out their 5G network, and they're facing a lot of challenges, as well as cities are being inundated with a lot of permits and telecom wanting to hang their small cell antennas. One of the areas and recommendations that we have also been provided to the telecom industry that we've created space for them is our ability to essentially light up an entire corridor with smart pavement. So our ability to deploy Wi-Fi, 5G, and bring in the edge that's supported by our roadside control center. This roadside control center allows us to do all of the real-time analyzing, computing, storing, and pushing the data to the cloud for a variety of reasons, not just for the public agency, for reporting purposes that will help with their traffic management, control, and other TISMO planning and operations. But it also is very valuable information that allows us to provide commercial services through the network that actually will help pay back and generate new revenue off of the road. So we're not relying on public dollars anymore to pay for upgrading our infrastructure system. So some of the other benefits that we're bringing to market that we've recently demonstrated is our ability to wirelessly charge electric vehicles through our smart pavement platform. So what we have done, and the reason why this design is pretty straightforward, is it allows us to integrate new and emerging capabilities, such as charging emitters for what we refer to as wireless EV charging, or from a technical term, it's dynamic wireless power transfer, better known as DWPT. So this allows us to put DWPT into road projects over traditional construction methods. What happens here is that the smart pavement system senses the presence of vehicles and engages in a handshake to determine if the vehicle is compatible with the charging elements, and to set up the charging profile if the vehicle needs a charge. So with the charging profile established, the smart pavement system ensures that the system is only turned on for qualified users and turned off when the vehicle has departed. So all this is happening in real time. We certainly can wirelessly charge electric vehicles in a parking stall, which is what we refer to as static mode. But what are demonstrating and going to be piloting is the ability to charge vehicles in motion, whether that's on a pedestrian street or a state highway. So we can certainly address more questions around that in the Q&A. But bottom line is that it's connected to and controlled by our roadside control center again, which is our micro data center. Also provides the edge networking capabilities. Power is distributed and managed by a power control system that's adjacent to the roadway. Components in the power controller tune and toggle the wireless charge field to match the needs of the approaching vehicle. So we're talking about efficiency at its best. So as smart pavement transforms the road into a software-enabled networking platform, again, new capabilities, new features and services can be deployed over the life of the roadway. So anytime we need to upgrade the road, we don't have to tear up the road, which is typically how roads are repaired and reconstructed. Is anytime a road needs to be rebuilt, you have to rip up the road. In this case, precast concrete has been studied by the US DOT and FHWA. It has a shelf life of 50 years, but as you know, technology increases year to year. And so because of our expansion ports, all we have to do to upgrade our roadway is to drop new sensors or antennas in or to replace old ones. So now that we know kind of the challenges that we're faced, not just within our local communities here in the state of Kansas, but across the country, and some of the new technology that is finding its way into the right of way to repair the roads for today, but also build out the network for connected electric and autonomous vehicles. We need to talk about how we get there, right? Transportation Secretary Buttigieg described the 2030s as the decade of connected electric autonomy. But for that to be realized, roads need to be transformed into network platforms providing managed services, which is what I've been talking about in the previous slides, right? So connected vehicles need dense distributed antenna systems and signal integration. Electric vehicles need in-motion wireless EV charging, which is what we're providing through our platform. And autonomous vehicles need in-road sensors to improve navigation, position, and telemetry. And all of these need edge networking distributed throughout cities. So at the same time, our roads need to be transformed to enable the next generation of mobility. Our cities, as we have identified already, are struggling. So what we're doing is doing a little bit of matchmaking. So we're identifying the states and municipalities backlog of unfunded projects that also would make really good candidates for the deployment of smart pavement. So it's not just about us, shoehorning our technology into a road that doesn't need it. What we're doing is we're identifying those 10 to 20% of assets along the public road, municipalities' roadway that need to be upgraded, that they just don't have any public funding for. And I'll explain a little bit more about our P3 model here in just a minute. Oh, there it is. So that's a great lead in. So what we have done is we have created a P3 model that's known as our Smart Infrastructure Program. So this is very much mirrors what cities do with their capital improvements, where they have identified their highest priority needs over the next 5, 10, 15 years. And what we'll do is work with them to identify not just their current plans, but which ones are a priority of theirs, but they just don't have any public funding for. So I mentioned that part of our ecosystem, our financiers, what we've done is created a new marketplace for very large capital institutions that are typically investing in multi-billion-dollar tollway projects or airport reconstruction rebuilds, and are creating this marketplace for them to deploy their assets, which is meeting several needs. One, it's meeting the needs of the city because they have an annual either deferred maintenance program that they can't fund themselves, or there's just a 5 to 10 year funding gap that they just can't raise enough taxes for. So the cities, the municipalities still own the right of way, right? But what it allows us to do is cities then provide a concession to our joint venture, our P3 organization, to design, build, finance, operate, and maintain the technology. So it really does become a win for the public agencies. It becomes a win for the constituents and the citizens. And it also becomes a win for all of the other emerging technologies that really are trying to provide some additional services to public agencies that may not be able to afford them otherwise. Just a couple of examples, and I'll open it up here for Q&A. Is we usually get asked, well, this is a great concept. Miguel, tell us where you've done it. And what we'll say is it's no longer a concept. what we had to do was go out of state to prove our technology. We partnered with the City and County of Denver and the Colorado Department of Transportation back in 2018 to deploy smart pavement along Brighton Boulevard, which was a corridor that was being redeveloped. It actually connects I-70 to downtown Denver. And what we proved there was just the design, the construction method, the deployment method, and then the operation maintenance on the back end. So it's been in the ground for the last 3.5 years. And what we've done is built our traffic data as a service platform, our commercialized services platform off of this installation there, which caught the eye and attention of a lot of other DOTs and other municipalities, including those here in our local region in Kansas City. And what that did was that it's sprung toward us into the opportunity with Lenexa, Kansas. So earlier in the presentation, I mentioned the support that Secretary Lorenz and Mike Floberg and his team have offered to the city of Lenexa. It really has provided us an opportunity to build a one-of-a-kind, first of its kind smart infrastructure program anywhere in the United States. So we've been working closely with obviously Mayor Bam and Becky Yoakum and her team, including Todd Pelham and Tim Green at the city to begin to identify and help them meet their 2040 objective, which is, as I referenced, they had a plan that they worked on over the past several years, and one of their objectives was to build an integrated infrastructure and transportation system. But they were going to have to rely on the private sector to help them do that. So what we have done and what we're doing right now is we're in the final design stage of the first phase of a 10-year opportunity. I mentioned our ability to privately finance our projects, and so what the city of Lenexa has committed to us over the next 10 years is to annually identify projects that make sense for their capital improvement plan. It also makes sense for us to deploy our smart pavement system. They get in real time the traffic data as a service benefit, some of the other benefits that come with the operations and management maintenance side of things. But then it also positions the city of Lenexa to really be the first city in the United States to have a wireless EV charging and autonomous vehicle transit loop that we're already looking at as for phase 2 and phase 3. So all this is being supported by a small award. I shouldn't say small, a significant award from KDOT. The city received a $250,000 award for this initiative, and then Integrated Roadways is privately financing the rest over the course of the next 10 years. So with that, I think it's probably a good time to pause now and just take a Q&A. I'd be happy to answer questions about the company, our technology, where we're going next, and anything about the Lenexa project, because I will have a call to action for all the other municipalities in the state of Kansas that we're talking to now, that also we could meet their needs and deploy our technology to help build out this network.
Awesome. Thank you, Miguel. We have many questions in the chat. I also put a link in the chat to our live feed for pavement engineering. So if you don't get your question asked there, or you have more questions after the session, put them in here and we can track that. So a few questions. Greg York asks, can cell phones be tracked geographically through the smart pavement system?
No, great question. We usually get a lot of privacy questions, but no, all of our sensors are embedded in the road. So all they're doing is collecting the actual tire pressures and axle counts that are driving over. So no, we're not collecting any cell phone information. Now, just to be clear, because of the roadside control center, there will be future deployments where telecom will be dropping in their small cell antennas. I think telecom, as you know, is already collecting your data information. That will be something that they address, but that's not what we do. We're the pavement technology experts.
All right. And so Josh Kobernick asks, does the in-pavement infrastructure you are speaking about have the potential to provide electricity to lighting the roadway with streetlights?
That's a great question. So we're looking at the microgrid, so the best answer is right now our interest is to address the auto OEMs and the need obviously to meet the net zero initiatives and helping the auto OEMs transition from combustible engines to electric vehicles. So our focus really right now is providing the infrastructure to address that need, obviously through our dynamic wireless power transfer system. But we're already getting approached about, how can we be a part of this microgrid that will help improve efficiencies when it comes to also buildings and light poles, and that space that we're going to have to explore with our other partners on the power side. So unfortunately, that's my best answer I can have. Our focus is really on the road and the vehicles, but last time I checked, there's a lot of buildings that abut next to roads, and we're all kind of trying to figure that out as well. So I imagine it will include more future discussions with partners in that space.
Excellent. Thank you. Haley Doherty has a handful of questions. I'm going to ask them and then you take what we can. We have 5 minutes left.
Sure.
Do you have an estimated cost per mile for installation? How easy it is it to service if necessary? Or do you have to replace an entire panel if an element fails? If it collects driver vehicle information, can you collect any driver behavior information like hard braking or speed information, things like that?
Yeah, great questions. I'm going to do my best to try to remember all of them. So how much the cost per mile right now, because it's precast, and again, there's technology embedded into it. It's not quite a 2x factor. So let's just say it costs a mile to do your traditional cast in place. It's not quite, because we've also done the cost comparisons. It's not quite a 2x factor. But obviously, once we have more of our product in the ground, we believe that our costs will not only be very comparable to how traditional roadways are being built now, but we believe it'll actually decrease as we build out a much larger footprint. And again, the other benefit to that is we can upgrade our road as new technologies come aboard. So you can't do that with current construction roads or cast in place or asphalt. So just kind of keep that in mind. I think we already addressed the I guess privacy issue and what we're collecting. It's fully anonymous. We do have if you go to our website, you're actually able to tap in to see our dashboard, and the dashboard right now is of the Brighton Boulevard project site in downtown Denver. So you can see in real time that it's just all aggregated information. But eventually here within, I would say in the next probably 12 months after we get the first intersection or two installed in Lenexa, then you'll start to see, that their traffic, anonymous traffic information that we're getting through our system there in Lenexa. So, and then I can't recall the other question. Lisa, you might have to help me out there.
Yes, the other one was about getting data on driver behavior.
Driver behavior.
Braking, speeds, things like that.
So yeah, some of the other applications that we're pulling through our system are for safety reasons. That's how we actually got started in Colorado, was identifying run off the road accidents in a rural part of their highway system, where unfortunately the only way they knew if somebody ran off the road was there was a missing guardrail. So what we're focused on are a lot of safety initiatives. So we're able to determine in real time wrong way vehicle detection, obviously start and stop, because we digitize the roads. I mean, if you're to think of the road now as a platform, the reason why I'm holding up a smartphone is because that's what we're doing. We're able to see everything in real time. And that's the next best place to be, not the technology above the road or at the road, but it's the road itself. So, obviously there's a big push around not just the net zero, but vision zero, which is about reducing the fatalities and number of accidents that are happening. So we're exploring a lot in that space. We have a software team that is that's leveraging our algorithms and machine learning and all this other stuff to make sure that we're making our roads and improving the safety of our roadways. So there'll be more to come around that in deployment with Lenexa, but what we already are demonstrating that now. One last thing I'll mention around not just that, but the way in motion is really important. a lot of our interstates and state highways are deteriorating at a faster rate because of overweight vehicles. So this is another one of the benefits that we're providing to public agencies in real time is tagging and flagging which vehicles are overweight, and then leaving it up to the municipality of how they would like to address that. But it's really intended to help with the operations and maintenance side of our roadways.
Thank you. I have time for, we're wrapping up. So in the chat, I'm going to add the other questions we haven't been able to get to the Pavement Engineering live feed. So check that out. And Miguel, if you can look at that once you take a breath and get some coffee, and hopefully we can get some other questions answered. But with that, thank you so much. Thank you so much, Miguel. This is absolutely interesting and really important information for what we need to be doing in the future. And we're glad you're here in the Kansas City area so that we can be working on it locally. And I'm excited to look at the project in Lenexa. So
yeah, looking forward to it as well. Thank you, Lisa. Thank you, everyone.
Awesome. Thank you, folks. We'll see you in the next session, which starts right now.